Welcome back to Print 101 at Fullerton College. This is Professor Ben Kiewit, and we're going to continue on talking about screen printing. We're also going to look a little bit more in depth at screen fabric. I kind of rushed through it last time because I was running out of time on my little timer of how long the video could be for YouTube. Anyways, here we are looking a little more in detail. Let's talk about the different ways of classifying your screens. What type of filament is being used matters, how high or low the mesh count is, what the fabric strength is, and the weave patterns. So the filament is talking about how many strands of whatever it is make up your fabric. Multifilament means you're twisting more than one together. Think like string or twine you buy at the store. There's more than one thread together, twisted until they make a thicker cord. That is stronger, but not as accurate for screen printing because ink can get stuck and spread between those twisted parts. One of the best things you can get for silk screening is monofilament. It's more uniform in how thick your ink goes, and you get better dimensional stability. It doesn't stretch as much, but it does cost more and it doesn't survive as long. More threads means more durable. Less threads means more accurate. So monofilament means you only have a single strand of whatever the material is. If it's a wire, it's a single wire. If it's a piece of nylon or polyester, it's a single strand of that. If it's silk, I'm actually not sure if that's physically possible, to be honest, and I've not looked it up. Anyways, so multi-filament gives you stronger weaves and stronger fabric that does not get worn out as quickly, but your ink film is not as even because you get irregular size of your shells when you start weaving it differently. That has to do with this picture as well, again, the fabric weave. Taffeta monofilament is like the best way to go for good high accuracy and small details, but it doesn't survive as long as a fabric as a twill or a gauze. Again, that's why they make pants out of twill, because it's a sturdier fabric. It's just not as good for dimensional stability or small detail printing. So the mesh count, it's kind of like thread count. If any of you guys are aficionados of very fine sheets on your bed, you know what thread count is. Thread count is how many threads there are in a linear inch. Similar to talking about line screen for halftone dots and for talking about dots per inch and image resolution, it's only a linear inch. We're not talking about a area computation. You don't have to do the squaring. But it just means if you go across a 1 inch, how many threads do you encounter in that 1 inch? So the higher the number of thread count, the finer the fabric is. Because think about it. If you take it to an extreme, let's just say you have a thread count of 1 thread per inch. Typically speaking, that means your thread is 1 inch thick, and it is in fact a pretty hefty rope. So 2 threads per inch would mean there's half an inch. So the more threads you have per inch, the smaller those threads are. So the higher the mesh count, the finer the fabric is. That also means the higher the mesh count, the less durable it is because it's thinner. You get a very, 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 very thin fabric that's almost not there. And you'll get amazingly high number, a very high number in your thread count. You get some amazingly good crisp detail out of it, but it's not going to survive very much use because you're putting all that stress into a very thin thread. Fabric strength has to do with how thick the diameter is. The thicker the thread, the stronger it is. Like I said, you already know this because you know that rope for hanging a swing off a tree is stronger than the thread you use to sew with. And you know that steel cables on the Golden Gate Bridge are much stronger than rope to hang swings off of a tree. The thicker it is, the stronger it is. Yes, I know there's metal involved in the Golden Gate Bridge, but don't wreck my analogy. In any sort of weaving, there are 2 things I want to learn about here. There's something called the warp and the weft. In a weave, the warp are the vertical threads and the weft are the horizontal threads. Hat tip to Mr. Glenn Hirth for this one because he says the right way to remember it is the weft goes from weft to white. So the types of fabric you can use. So we were just talking about how many threads per inch and if there's 1 or multiple threads per strand. Now we're going to talk about the types of things they're actually made out of, because you can have silk. Traditionally, it was silk. That's why it used to be called silk screen printing, and some people still call it that. Silk is expensive. It always has been. It's not gotten easier to make since the ancient world because you're still harvesting silkworms, and you have to grow them and tend them and take care of them and then take their cocoons later on. And they don't make much per bug. So it's still a labor-intensive, difficult process to get silk. Also, it's not as durable necessarily as some of the synthetics we can make. So polyester and nylon are popular. Those are both synthetic fabrics made out of plastics, basically. Also, metal and metallized things are also a possibility. You can use basically a screen door type screen, something made out of actual metal filaments. And those are useful for industrial applications where durability and long runs are important, but you really don't get a very fine detail if you're using metal threads. So, silk, while it is amazing, um, it's pretty good and durable, and it has very good dimensional stability, but it has some problems with some of the chemicals we use to clean up because organic solvents will sometimes just eat right through it. Um, anyways, there are advantages and disadvantages to all of them. Polyester is synthetic, and it can be multi or monofilament, and it's a little bit better as a multifilament because it's not quite as strong as some of the other ones. You get a better uniformity off of mono, but in more durability off of multi. It's good dimensional stability, and it's very popular. Nylon is also quite popular, and it's only usable as a monofilament and adapts well to rough surfaces. The dimensional stability, meaning those little squares you make don't stretch. And it's useful on weird surfaces. If you're printing on like a baseball cap or on the outside of a bottle, nylon is the way to go. Metal mesh can be bronze, copper, or brass, and it has problems with some kinks and deformities in the mesh itself. So you may get some weird issues in the actual surface of your screen. When dimensional stability is more important than anything else, this is the way to go. This means you can print with heated inks on plastic. You can survive extreme heat because it's going to be a higher melting temperature for your screen than any of the inks you're using. And most solvents are not going to do a whole lot to it at all, but it can break. So let's go on to talk about fabric. I actually believe I already covered that a little bit in my other side video I've edited in here, the way you attach the fabric. Some of them I didn't show because I couldn't find them in our lab on short notice to videotape, but it can be stapled on, which if any of you have painted on a canvas, you know that a lot of those are stapled. Yes, well, thank you for asking. I do actually stretch my own canvases. So stapling is one way. Something called Chord and Groove, which I could not find the one of to show you this time, and I'm sorry. It's a very strange thing where you hammer a little rubber hose into a groove to help hold it in place. Mechanical clamping and adhesive bonding are the ones I showed you in the side video.
This screen frame is admittedly not in the best of shape, but we'll take a look at it anyways. It's a little old, it's in need of repair, but this is what I found when I went digging through cupboards of Sam's stuff. Don't tell Sam, he'll kill me. So this is also the monofilament nylon, and that is the mesh material. The yellow color helps reduce the spread of UV light when you expose, and this is attached using a mechanical attachment system. You can see that it fits into the groove on the back here, and it gets tightened by these bolts to re-stretch it as needed. The advantages of this type is you can take off the screen and store it not on the frame and then re-stretch it when you want it. Although that does sometimes cause problems, that lets you do that. And that also means if it starts to sag and lose that tension that you need to keep good dimensional stability, you can get out here with a wrench and crank it back down until it's tight again.
Stapling is the weakest and the worst thing to do, by the way. By putting extra holes in your screen and putting tension only on the parts where those staples go through, you're putting strain and possible tears on your screen. Chord and Groove is popular, but it's good when you don't need to have any extra high degree of accuracy, because Chord and Groove is not going to give you quite the same level of dimensional stability. And yeah, it's not really recommended to be done. Mechanical clamping is good. It's on a lot of metal frames and it lets you tighten the fabric to whatever tension you need. It also lets you take the fabric off and store them and use one frame from any screens that you switch between. So there are some advantages for mechanical. Adhesive bonding is what we mostly use on campus, and that means you basically super glue it on. It gets clamped and stretched to a point where it's going to stay, and then a lot of adhesive is applied to the whole back of the frame, and it glues on. This is good because it gives you very good detail. You don't get a whole lot of cell distortion. You do need a stretching machine to do it, though. You're not able to do this one just by hand. All right. We're going to come back in another video to carry on with this little chapter. Thank you for listening.